Today, what we're going to do is we're going to compare series and parallel circuits, okay? Yesterday, we did series circuits. Series circuits is very simple. When you're doing total resistance, you're just adding all the resistance up. But today, when we're talking about parallel circuits, it's different. Because if you want to understand, electricity goes in this direction, but the electrons go in this direction, okay? And so what's happening here in the series, it's going through, if you're talking about electricity, it's going through and it's going to this resistor, it's going through that resistor, it's going through that resistor, and it's coming back. It only has one path. But when we're talking about a parallel circuit, we have the same voltage here, but the voltage here can choose either path A or path B. For that reason is the reason why the math is different. So if you look, the first one is the total resistance. So for a series, one thing you have to do is just add them all together. Now make sure from yesterday we talked about it. If they're in kiloohms, you can keep them in kiloohms, make sure they're all in kiloohms. If you want to convert them to ohms, please do that. Either way is fine as long as your units are correct. Okay? So if we're looking at total resistance for a series, we're just adding them up. I want to make sure that you understand resistors and along with volts and things of that nature change the circuit's voltage. So if you look at parallel circuit, what we're going to be doing is we're going to be doing the inverse of these resistors. So we have 1 over R1 plus 1 over R2 plus 1 over R3. If we had 4 circuits, we would have just added it on. You look on the right-hand side is where I'm showing you how the math is. Now, this one here is in ohms. This one was in kiloohms, so I just went ahead and did the conversion for ohms because I want to show you how to do both. It doesn't matter if you keep it in kiloohms or if you do it in ohms. Just make sure you understand your units have to match throughout the process. So the first thing I would like you to do is I would like you to get your calculator function on your computer, please. So get your computer. Open it up to your calculator. And we're going to do this step by step together to make sure you know how to do this on your calculator. Because yesterday's homework for those of you that were at home was actually doing the math section, not using the FIP, which we're going to go over tomorrow. So what we want to do is we want to do this inverse of your resistance. So if you'll just stop for a second, open up your computer, get on your calculator. I want to physically see everybody be able to do it on their calculator today, so that if you did not finish your work yesterday, you can finish it tonight so you'll be ready for tomorrow. It will be on there, it'll be on there.
What are we going to now?
We're going to your calculator. One, two, three, 4. It should be the bunny. Oh, you're good. Okay, so let's turn our calculator on. we're going to hit the alpha Y enter button, please. And what we're doing is we're going to try to put this number in our calculator, guys. So we have that. So we want to put a 1 because we're doing that. Go down to the bottom. And then I want you to hit alpha Y, enter again. And that's going to give you a fraction for a fraction. Everybody there so far? Okay? So now what I want you to do is I want you to put a 1 over 470. I want you to hit the side button to go over. We're going to add this, so put the plus sign. Alpha Y, enter again. You're going to do your 1 over 2200. That's the number we've got because I'm changing this now to ohms instead of kilo ohms. Plus alpha Y, enter again. And we're going to do 1 over 3300. And then we're going to hit the over button twice to get up to the top and hit enter.
What's that? 2.2K?
Well, I'm going to do mine in conversions. So I did the 2,200 ohms, sir. And then the third one, Hunter, I did 3,300. Is everybody good? Everybody got 346.59. And that's the hardest math we've got to do today. So what that's going to give us is the total resistance. Did everybody get it? Fantastic. So what I did is I just changed this to 350 ohms. The next thing I want to do is, just like I did yesterday, I want to find the voltage across the components. So based on Ohm's law, it's telling us the voltage that goes through V1, V2, or V3 are all going to be the same as the battery. So then that means my voltage total will equal 15 volts. The third thing that I'm going to do is I want to see the current through each component. So I want to find with resistor 1, resistor 2, and resistor 3. To be able to do that, the only thing I'm going to do is I'm going to take my voltage and divide it by my resistance. I did it through ohms, and I also did it through kilo ohms. And that's where I got that number. I do the same thing for my second one. I take my voltage, which is 15, and I'm going to divide it by either 2.2K or 2020. 2020, I'm going to get this. 2.2K, I get that. This is milliamps. Then I go through and say, all right, I'm going to do the third resistor. 15 volts again, because my voltage never changes. And this is 3.3 kilo ohms, which gives me 4.5 mega amps. And then after I've done every one, if I had a fourth one, I would do the same thing as what I did here. When I get done with all of my current, then what I'm going to do is I'm going to add these three together. And I'm going to divide that by my voltage, which I got 43 milliamps. And then the last thing I'm going to do is I'm going to check the law. Remember what we talked about 2 days ago? We have KPI and KCI. For parallel, we're going to use KCI. So it's telling us that the current total should equal current in 1 plus current in 2 plus current in 3. So what I did is I took my IT, which is my total current, which is this number right here. And then I went through and I added each one of those in, this one, and this one. And when I do that, it balances. The same thing as what I did with the series circuit yesterday. Questions?